Hi everyone. We're going to discuss forecasting using trend linear regression. This is a statistical method used to predict future values of a variable based on its past behavior. Essentially, it's a statistical technique that finds the best fitting straight line to represent the relationship between two variables. In forecasting, one independent variable, or predictor, is typically time, such as days, weeks, months, or years. The other is the dependent variable you want to predict, such as stock prices or, in this case, sales of iPhones. The goal is to determine the equation of the regression line, y equals intercept plus slope asterisk x. Here, y is the predicted value, the dependent variable. X is the time variable, the predictor, or independent variable. The slope of the regression line is represented by b1, and b0 is the intercept, the value of y when x is 0. If you look at the table, we have data on iPhone sales from week 1, Monday, February 3rd, to week 9, March 31st. We need to forecast the iPhone sales for week 10, April 7th, 2025. Remember, forecasting uses historical data to make predictions about future values. Linear regression lets us project the trend line into the future, giving us estimates of potential iPhone sales. We're going to estimate the intercept and slope of the trend regression equation. As highlighted in yellow, the trend regression equation is y equals b0 plus b1 multiplied by x. Again, b0 is the intercept, and b1 is the slope. Let's calculate these values. In Excel, to find the intercept, you type equals intercept. For the known ys, select the iPhone sales data. For the known xs, select the time data, weeks 1 through 9. This gives us an intercept of 245.78. We do the same for the slope, typing equals slope and selecting the same data ranges. This gives us a slope of 6.93. So, our regression line equation is y equals 245.78 plus 6.93 multiplied by x. In the Excel table, you can see the weekly iPhone sales data in column C. This starts with the first week, Monday, February 3rd, 2025, and continues until week 9, March 31st, 2025. Our task is to forecast the iPhone sales for week 10, April 7th, 2025, using this regression line equation. To calculate this in Excel, click on the cell where you want the result, then type equals intercept. Highlight the known y values, iPhone sales, then type a comma. Next, highlight the known x values, time periods. Close the bracket and press enter. You can calculate the slope similarly, type equals slope, highlight the known y and x values, and press enter. This will give you the complete regression line equation, y equals 245.78 plus 6.93 multiplied by x. After calculating the forecast values in column D, we need to calculate the forecast errors in the next column. Forecast errors are important, they tell us how accurate our predictions were. Essentially, they quantify the difference between our predicted values and the actual outcomes.
Mathematically, a forecast error is simply, forecast error equals actual value, forecasted value. We'll calculate these errors in column E. Forecasting is never perfect, there will always be some degree of error. However, understanding the size and pattern of these errors is crucial for evaluating and comparing the effectiveness of our forecasting models. This allows us to make informed decisions based on the most accurate model. We can gain insights by evaluating positive and negative errors. A positive error means the actual value was higher than our forecast, we underestimated. A negative error means the actual value was lower than our forecast, we overestimated. Analyzing these errors can reveal biases in our forecasting methods. While the basic concept of forecast error is straightforward, there are various metrics used to summarize and analyze them. These include mean absolute deviation, MAD mean squared error, MSE root mean squared error, RMSE mean absolute percentage error, MAPE. The significance of a forecast error depends on the context. A small error in a high-stakes prediction might be more problematic than a larger error in a less critical forecast. In summary, forecast errors provide vital feedback on the accuracy of our predictions. They allow us to continuously improve our forecasting processes and compare the performance of different models, such as trend forecasting versus moving average forecasting. In the Excel table, the yellow highlights indicate forecast values. The blue highlights show the performance metrics of the trend regression model, MAD, MSE, RMSE, and MAPE. The green highlights show the performance metrics for the 3-week moving average model. Here are the formulas for these common forecasting error metrics. N equals number of forecast points. Vertical bar represents absolute value. For example, vertical bar 3 equals 3, mean absolute deviation. MAD measures the average magnitude of the errors, without considering their direction. Formula, MAD equals 1/n, sigma vertical bar actual value, forecast value vertical bar. Mean squared error, MSE measures the average of the squares of the errors, giving more weight to larger errors. Formula, MSE equals 1/n, sigma, actual value, forecast value 2. Root mean squared error, RMSE is the square root of the MSE. It provides an error metric in the same units as the original data. Formula, RMSE equals MSE equals 1/n, sigma, actual value, forecast value 2. Mean absolute percentage error, MAPE measures the average percentage error of the forecasts. It's useful for understanding the relative size of the errors. Formula, MAPE equals 1/n, sigma, actual value, forecast value, actual value vertical bar 100%. Important notes regarding MAPE. MAPE can become undefined or unstable when actual values are close to or equal to 0. MAPE is not symmetrical, meaning over-forecasting and under-forecasting are not weighted evenly. Now, let's discuss how to forecast with a 3-week moving average, MA, using your weekly data from week 1 to week 9. Imagine you're trying to predict sales for week 10 based on the previous week's performance. The basic idea. A moving average smooths out fluctuations in your data by averaging recent values. A 3-week moving average specifically calculates the average sales from the 3 most recent weeks to make a forecast. Here's how it works step by step. Start with recent data. To predict week 4, you'll average the data from weeks 1, 2, and 3. To predict week 5, you'll average the data from weeks 2, 3, and 4. And so on. Calculate the average. Add up the sales figures for those 3 weeks. Divide the total by 3. The result is your forecast for the next week. Moving the window. As you move to the next forecast, you drop the oldest week's data and add the newest week's data. This is why it's called a moving average. Forecasting week 10. To forecast week 10, take the data from weeks 7, 8, and 9. Add those values and divide by 3. Why moving averages are useful. Smoothing reduces the impact of random spikes or dips in your data. Simplicity, easy to understand and calculate. Short-term trends, can capture recent trends in your data. Page 5. Things to keep in mind. Lagging, moving averages lag behind the actual data, meaning they might not react quickly to sudden changes. Choosing the period, the 3 and 3-week moving average is a choice. You could use a different number of weeks, like MA2, MA4, or MA5. Compare the performance metrics to select the best model for your data. Seasonality, moving averages do not account for seasonality.